Depending on your time zone, good morning, good afternoon, or good evening. I'd like to welcome everyone to AIC's Everything You Wanted to Know About Intel's PCIe Gen 4 But We're Afraid to Ask webinar. This webinar is presented by AIC, and my name is Joe Kimpler. I work in AIC's Office of the CTO, and I'll be your moderator today. Before we start in the classroom, let me provide a quick overview of the webinar's format and some quick start tips. The webinar is broken down into 3 modules: a briefing on the new PCIe Gen 4 advantages, Intel's new 3rd generation processor, and then uplift the discussion on how it will benefit new server architectures and your business. If you would like to ask questions, please type them into the chat box, and they will be answered during the Q&A session at the end of each presentation. For deeper technology discussions with each presenter, we encourage you to join our virtual happy hour following the Q&A session. Lastly, all of the presentations will be available for download from the handout section of the GoToWebinar and will be posted to AICIPC.com for future reference. The main presenter will be AIC's Alan Yu. Alan has been at AIC for over 6 years and is one of the product engineers for our new server boards and platforms. Alan will be highlighting Intel's new 3rd generation Xeon offering and then provide a technical deep dive into how this new processor provides the engine for AIC's powerful new server and storage platforms. Normally on open webinars, we get a variety of levels of experience. To ensure that everyone has the same baseline, we are going to spend a few minutes to provide a quick overview and a reminder of PCIe Gen 4 specifications. Please do not confuse this with Intel's trademark terminology. 3rd generation Intel Xeon processors, they're different. So let's review the PCIe Gen 4 evolution, speeds and feeds, and physical connections. This slide is a PCIe roadmap from the Peripheral Component Interconnect Special Interest Group, or PCIC. This generational roadmap you are seeing comes directly from the PCIC. It is an electronics industry consortium responsible for specifying the Peripheral Component Interconnect, PCIX and PCI Express computer buses, and is based in Beaverton, Oregon. The PCI has been around since 2003, and there have been several generations. As you can see, with PCIe 4.0 was ratified in about 2017. Like any new standard, it has taken several years for the ecosystem to develop for the mainstream to be able to take advantage of the performance and feature improvements. Let's discuss some of the advantages. Alan, now that everyone has a good understanding of the PCIe roadmap, let's take it down and compare PCIe Gen 3 versus PCIe 3 Gen performance characteristics.
The PCIe Gen 4 and PCIe Gen 3 is very similar and are backward compatible. The main difference is PCIe Gen 4 is twice as fast as PCIe Gen 3, and the PCIe Gen 4 speed is 2 GB per second data rate for a single link. For a by 16 connector, the data rate is 32 GB per second compared to its predecessor at 16 GB per second.
Let's talk about the physical interfaces available for design and integration for the motherboards and components like SSDs and GPUs.
For the physical connector, it's still remaining the same with by 1, by 4, by 8, and by 16. But the most important part is the double in bandwidth. With the Gen 4 by 16, we can run HDR at the full speed. Even the NVMe drive is getting performance boost from PCIe Gen 4 increased bandwidth. The performance can be extended to the network card via the increased speed per lane to the network card.
Thank you, Alan. Now let's get into the meat of the webinar and discuss the features and functionality of Intel's 3rd generation Xeon scalable processors. Alan, can you provide a quick update for our audience on the new Intel offering?
The new Xeon processor has dramatically increased the number of cores per socket over the previous generation. There are up to 40 cores per socket and have a clock speed of up to 3.7 GHz. This provides an overall performance increase of about 46%. The increase takes all foreign computing to the next level.
In addition to the raw hardware improvements, Intel's new processor is also offering additional performance functionality like Intel SGX, DL Boost, SST, and other features. Let's break them down for the audience, Alan.
Intel has improved many features in the new release, but I like to focus on 4. Software guard extension, deep learning boost, speed select technology, and crypto acceleration.
Let's unpack the software guard extension feature. Alan?
Intel Software Guard Extension, or SGX for short, in a nutshell is a set of instructions that increases security of application code and data, giving the end user more protection from disclosure and modifications.
Alan, here's a high-level diagram of software guard. Without going into too deep of a dive, please explain it to the audience.
The third-generation processor helps prevent hacking, such as memory bus snooping, memory tampering, and code boot attack. It also protects against software spoofing, even if the OS, driver, or BIOS are compromised. And we do take advantage of these features in our AIC-built platforms.
Moving along to some example, here's AIC's Tucana motherboard. Alan, can you give a quick description of the Tucana motherboard?
Thanks, Joe. Our Tucana motherboard is an extended ATX form factor and designed with software-defined storage application in mind. This allows us to take advantage of Intel Software Guard extension. It also has a better thermal characteristic with a square core design, and we focus on standard rack-mounted unit from 1U to 4Us.
Moving on to another platform, AIC also has a new motherboard called Sail. Alan, can you go into the advantage of this new design?
Yeah, AIC Cell motherboard offer a lot of external I/Os in a 1U form factor. It is all PCIe Gen 4. We have the capacity for 2x16 PCIe cards and an OCP 3.0 card. These are all installed into a riser using a space above the motherboard. We utilize this type of design in our 2U4 nodes and other multi-node server. We also have PCIe lane located at the front of the motherboard to help power NVMe devices for our bare bones.
Another new Ice Lake board is Pegasus. Alan, can you explain the features and functionalities of Pegasus?
For this motherboard, I'll focus on AIC MaxIO technology. MaxIO is an innovative way of pulling the PCIe signal to create solutions for your unique form factor. It's an adaptable hardware programmable interface. By intercepting the PCIe signal at the processor, enable the designer to route, bifurcate, and manage the PCIe signal. This allows for the management of PCIe lane individually, or they can be combined to be managed as a group. This allows AIC engineers to design in the maximum level of I/O expansion using the minimum of real estate. Riser card can be used to create a multitude of I/O expansion possibilities. In AIC Pegasus motherboard, we utilize AIC MaxIO by implementing all of the PCIe lane on the edge connectors. We can redirect the PCIe lane in any shape or form to fit certain applications. In bare-bone level, we can create extremely dense I/O for networks and graphics cards.
Moving to the Deep Learning Boost feature, can you go into some details on how AIC takes advantage of it?
Yeah, Intel Deep Learning Boost take embedded AI performance to the next level. Intel's instruction set architecture feature on x86 designed to improve performance on deep learning tasks such as training and inference. Deep learning workflows optimized to use Intel Vector Neural Network instruction set, known as VNNI, will gain a significant performance boost. This is an extension of the AVX512, which doubles the performance. Examples of VNNI workloads are image classification and object detection.
Alan, thanks for unpacking the deep learning functionality. Can you provide the audience some examples of how AIC takes advantage of this feature?
Okay, Joe, here's an example. AIC CB121 take advantage of these features in video surveillance verticals. The CPU can help release some of the stress of the system's GPU. If the surveillance system is running facial recognition software, it can identify the individual and compare them with a known criminal database. As we all know, this activity can require teraflops of processing power. CB121 is designed for these type of applications by offering a by 16 double deck slot along with another by 16 full height half length. The system also supports up to 4 NVMe drives, reducing the latency between storage and I/O. Besides using it for video surveillance verticals, The CV121 cell also excels in other verticals such as research, edge application, and general GPU computing systems. In the research field, it requires the ability to process terabytes of data collected on the edge and transfer this critical information into storage. With this, it requires extremely fast storage, GPU that can process a terabyte of data, and an ultra-fast networking that can transfer the result back to the main storage. For smaller scale general GPU computing that require on-the-spot processing, this platform excels at running applications such as image classification and object detection. Edge applications require massive data processing before sending it back to the cloud. The CV121 vastly reduces the requirement for data exchanges between the IoT and the cloud.
This brings us to the Speed Select technology. Alan, please give us a view into how it offers a more granular control over the CPU's performance.
Intel Speed Select technology is a process-based power management feature that provides multiple CPU performance configurations for users to choose and set different frequency range to different cores according to their computing needs.
Setting the processor core's frequencies differently provides a tremendous advantage to the platform. How does AIC take advantage of this important feature?
Our HP 201, 202 come in a 2U 4-node form factor. Using the same hardware but configured differently allows AIC platform to support multiple use cases with the same hardware. Additionally, the 2U 4-node server take advantage of the high core count of the new Xeon scalable processor for hybrid converged infrastructure solution, while offering the flexibility of SST. Lastly, the increased processing performance is enhanced by its rich I/O capability. The HP 200 series platform offers 3 PCIe Gen 4 slots. 2 of them are PCIe by 16, and the last is OCP 3.0.
The last feature we're going to talk about is crypto acceleration. Alan, can you bring everyone up to speed?
Yes. Today's data is cryptographically protected across layers of software, network, and storage stack, resulting in potential for multiple operations being performed on every byte of data. These cryptographic operations are very compute intensive, yet they often support critical business operations where security is paramount.
Using this diagram, let's unpack the crypto acceleration's value proposition.
Intel reduced the cost of cryptographic computation by encrypting the data through new instructional set, microarchitectural improvements, and software optimization. As a result, the industry has increased the use of strong cryptographic ciphers, better securing data and communication. Taking advantage of this is AIC Network Security Division. Our security portfolio includes NES and FIPS 140-3 enabled platforms.
System memory is another critical factor in compute performance. Alan, please provide us an update on the increased memory capabilities.
The third generation Intel Xeon scalable processor has up to a 16 memory channel in a dual process configuration. It can support up to 3200 MHz of memory frequency. Using Intel Optane memory, the servers can support up to a total of 12 TB of memory.
Can you translate this into AIC advantages for our new SB101-A6 platform?
The SB101-A6 utilizes 16 memory channels and has 32 DIMMs of memory on a single motherboard. This much memory enables in-memory computing. In-memory computing allows the system to store and process data in the RAM, which is about 5,000 times faster than traditional spinning disk. Besides the massive amount of DIMM slots, we offer up to 8 NVMe drives or a mixture of HDD and SSD for tiered storage. To keep pace with this lightning fast storage, we match it with 3 full PCIe Gen 4 slots, thus balancing the design performance and capability.
Moving from memory speed to PCIe Gen 4 lane capabilities, let's provide the audience with the latest update.
Intel new architecture increased the number of physical PCIe lanes from 48 to 64. This is an increase of 16 per CPU. Not only is there an increase in the number of PCIe lanes, but the physical speed is double versus the last generation. This means we could use less to get the same performance.
How does this translate into platform performance?
We take full advantage of this in our CB201 Pegasus, where we utilize all 128 PCIe lanes and make it available for I/O cards. We're able to achieve this with AIC Max I/O. The server can support a total of 8 PCIe slots in a 2U form factor. This massive amount of I/O capability is perfect to use for head node or any other I/O intensive applications.
Now, let's quickly cover how AIC has incorporated the new Ice Lake into our storage servers and the resulting benefits.
For our storage line server, we focus on Tucana motherboard. The SB101 Tucana is designed with up to 8 NVMe drive or a mixture of HDD and SSD for tiered storage. With this extremely fast storage, we match it with 3 PCIe Gen 4 slots to ensure that the design is balanced. Additionally, all 3 of the PCIe Gen 4 slots are functional even if the design is powered by a single processor. We took the same Tucana motherboard and added it into one of our best-selling chassis to create the SB202 Tucana. This unit is not just a standard 12-bay server, but it supports tri-mode. Each of the 12 bay can support SAS, SATA, and NVMe right out of the box. With only a few modifications, there can be several variations of this unit. For example, one of the most popular versions can support up to 2 double-deck GPU cards. Providing additional flexibility and system compatibility, the same motherboard can be used across all AIC 4U storage servers, including the 24-bay, 36-bay, and 60-bay platforms.
Thank you, Alan, and let's review the information that's been presented. On PCIe Gen 4, it's part of the PCIe SIG roadmap and was released in 2017. It has twice the speed of PCIe Gen 3 and is backward and forward compatible. It accommodates physical connections from 1 by to 16 by. On Intel's 3rd generation Xeon, it's 40 cores per socket and with clock speeds up to 3.7 gigahertz. This provides an overall performance increase of about 46%. There are also several new features, but the key ones we talked about are the deep learning boost, software guard extension, speed select technology, and crypto acceleration. Now let's review how AIC maximizes these new capabilities in our new motherboards and platforms. On the motherboard side, Tucana is an EATX design and is perfect for SDS applications and storage servers. Sail is a half-width design and is perfect for multi-node environments. Pegasus is another half-width design, and it maximizes the flexibility of I/O via AIC's Max I/O. On the platforms, the CB121 is perfect for security and surveillance, research, and other GPU workloads. The HP 201 and 202 is a 2U4 node and is designed for higher core counts and extensive I/O capability. This is perfect for hyperconverged infrastructure solutions. On the SB101-A6, it provides incredible memory capabilities, enabling in-memory computing and drive flexibility for backup as a service applications. The CB201 has massive I/O capabilities and is perfectly suited for head nodes or any other I/O intensive application. For our storage servers, the SB401, 402, and 403 come in 24, 36, and 60 bay configurations. Hello, this is Joe Kempler. We have several questions in the chat box, so let me try to answer them in order. Well, the first question is, can I upgrade my current AIC chassis with the new motherboards? Al?
Yeah, this is a really complex question, and it really depends on the system. Some of the changes might only be the riser cards on one platform, and some will require a more extended change, such as rear windows and like the retimer, the redriver in the system. So the best way for us to answer this will be if we contact our field engineer and we'll take a look at what you really have and how to upgrade to the next generation.
Thank you. The next question is PCIe Gen 4.0 more energy efficient compared to Gen 3? And can it help reduce TCO?
Yeah, in the context of individual cards, it will increase your performance with about the same power. So if we look at, let's say, a network card, the old generation is running about 100 gigabit per second, and the new card right now could run about 200 gigabit per second, and is relatively the same energy consumption on that.
Thank you. The third question is, can I just replace my processor with my Xeon Scalable 2 Gen 2 motherboard?
No, that's definitely something that cannot be done. So the physical socket of the CPU is different between Gen 2 and Gen 3. The Gen 3 has 4,189 pins, and the Gen 2 have about 3,647. So there's a big pin difference between the two.
Excellent. Thank you for making that clarification. Let me see. The fifth question is the Xeon Scalable Gen 3 going to have a shorter life cycle since Intel is already working on the next release?
No. On every generation, there will be a overlap. And there's no expectation that this will be a shorter life product versus other generations. Okay.
And that's really good for anyone using this on the embedded side because it'll have a 5 to 7 year life cycle. Next question is the environment/ecosystem ready for PCIe Gen 4 systems?
Yeah, it's like, as I mentioned in the presentation, the PCIe Gen 4 has been around since 2014. And a lot of manufacturers started to release PCIe Gen 4 products, network cards, graphics cards, and recently there's a lot of drive manufacturers that start releasing Gen 4 drives as well. So the whole ecosystem is catching up and is pretty much, I would say, pretty ready for the switch over.
One quick update to that is the PCIe Gen 4 was actually released in 2017, not 2013. Going on to the next question. A lot of Intel questions here. Are persistent memory modules supported on AIC motherboards?
Yes, we can support persistent memory such as Intel Octanes. And with that, we could support up to 12 terabyte of memory with our units such as the SB101A6.
A couple more questions have piled in. Let's see. What is the benefit of using PCIe Gen 4 NVMe drives?
PCIe Gen 4 NVMe drive. The main benefit of using PCIe Gen 4 NVMe drive is the boost in the performance. So from our testing, some of the drives that we see about 4 times more IOPS versus the Gen 3 version. So we do see a lot of promises from these drives, or they look really promising.
Okay. Next one. Is there any performance impact if I use Gen 3 cards in a Gen 4 system?
So the question is, if we use a Gen 3 card in a Gen 4 system, will there be any performance impact?
Correct.
Okay. All right. If we're speaking of just on Gen 3 speed, there will be no performance impact if you're using the Gen 3 or Gen 3 card used in the Gen 4 system since it's backward compatible, right? The only thing is you will not get any performance gain for using a Gen 4 system while using Gen 3 card. It will be the same speed as what you're currently seeing.
Okay. Here's a question that just popped in. any of your Ice Lake systems can provide 40 gig to 80 gig network bandwidth as high as my performance storage solution. It looks like they're asking if there's a 40 to 80 gigs of network bandwidth that can go with his high performance storage solution. Sounds to me like it would depend on the networking card you put in.
Yeah. It depends on the network card you put in, and for a lot of our servers, we have support for multiple network cards, so we could increase the bandwidth by quite a bit.
Next question is, do they support 200 gigabit Ethernet or IV? Can you use RDMA to write from the network card to the GPU via PCIe Gen 4 without hitting the system memory?
Yes. Short answer is yes.
Okay. Next question that came in just on the chat. Do you have a performance comparison between new PCIe Gen 4 and those already out from AMD?
Performance as in...
So it sounds like he's asking, have we done a bake-off between this PCIe Gen 4, the Intel, and the AMD Gen 4?
That, us personally, no, we have not done that. Yes, so there's probably information of that online, but for us, we have not done a performance evaluation between the two.
Alan, let me add a little bit of color on that. It should not be any impact on performance since actually PCIe Gen 4 is a standard. So both manufacturer of processors, they should follow the same technologies. So the performance impact will be more card to card or card to manufacturer than platform to platform.
Okay, the next question that came in is, on the 4U 60-bay Ice Lake storage server, besides 63.5, are there 2.5-inch slots or NVMe slots for caching? Sounds like somebody really knows our AIC products on this one.
Yeah, we have 10 NVMe drives that is supported for our 4U60 on the back side. That could be either it's tri-mode backplane, so it could be SATA or NVMe in those. Yeah, and that's good for caching applications.
Next question is the power consumption on the Xeon Scalable 3 less than Gen 2? Sounds like it's asking the question between the Intel Scalable Xeon Gen 3 and Gen 2.
Oh, the power consumption.
Yes.
The power consumption of Xeon Gen 3 and Gen 2 is very comparable. But with Intel Gen 3, there are higher core count CPU. Therefore, on the high-end level, we'll have higher TDP CPUs for the Gen 3.
Thank you. Any additional questions? Here's one that just came in. Again, this sounds like somebody knows AIC products. The SB101 and SB202, as you mentioned, SATA, SAS, and NVMe support. Does that mean I can use one base system to make my storage server and a flash server? If yes, can you make it easier to use? That's a little worded a little funny, but there you go, Alan.
Yes. So right now we can use both hard drive or NVMe since our 3.5-inch drive tray does support 2.5-inch drives. And then our backplane supports SATA or NVMe. What's the second half of that question, Joe?
Is it if the answer is yes, does that make it easier to manage the hardware?
Yeah, I would say it'll be a bit easier since you could run it all from one unit for doing the tiering storage instead of having multiple units to run different type of storage. So if you're looking for all in one box, then definitely it'll be easier to manage.
Yeah, also for the hardware side, you don't need to take care of dual piping. If you want to use NVMe or SATA SAS, you can use pretty much all the connector available and just plug in the drive, which drive you want to use, SATA SAS or NVMe, and no worry about the internal part of the box.
Are there any additional questions out there? Let's the end of the questions in our chat box. Go ahead and feel free. We're going to unmute your mics so that you can ask questions in an open forum. Everybody is now unmuted. Please feel free to ask questions to the team here. Any questions for our experts? We'll allow another couple seconds for people to think about their questions, or you can type them into the chat box. Well, if there are no additional questions, we'd like to thank you very much for attending the AIC Everything You Wanted to Know About Intel PCIe Gen 4 But We're Afraid to Ask webinar. As a reminder, please rate this event. We value your feedback. We also post the presentations to www.aicipc.com. Please follow us on YouTube, LinkedIn, and Facebook. There's our addresses. Again, we'd like to thank you very much and make it a great day.